Hey everyone, welcome to the Unhandled Exception podcast. I'm Dan Clark and this is episode number 59. Now, I'm sure a lot of developers have heard of terms like hexagonal architecture, ports and adapters, onion architecture, clean architecture and so on, but I bet that most don't really understand what that actually means and what the differences are between them. And if that's you, hopefully this episode can help you out. Because today I'm joined by Valentina Cupać to chat all about hexagonal architecture and to try and demystify what that is and how it compares to other types of architecture I just mentioned. So Valentina, welcome to the show.
Thanks a lot. I'm really excited for this session today. Thanks for the invitation.
Oh yeah, welcome. I'm looking forward to seeing how we do this without diagrams and things. That should be interesting.
Yes, definitely.
So could you introduce yourself to the listeners and tell us a bit about what you do?
Yes. I'm a technical coach at Optivem, and I help companies and teams to increase the level of software quality within their development practices in order to speed up delivery and to reduce bugs and increase overall also satisfaction of the development team. And the way I do it is typically by introducing hexagonal architecture, clean architecture, and also test-driven development practices. And I help teams to introduce this on their real projects. So these are not some simulated or kata-like projects, but actual real production-like projects so that they can see that these are not some theoretical academic practices, but that, yes, this does bring real results in actual production projects.
That sounds really fun, actually. I'm assuming you've seen lots of different code bases of different, let's say, quality levels whilst you're going in and introducing this. It does sound quite an interesting role.
Yes, I have seen various projects in various languages across various countries, and the surprising aspect is that I've seen similarities in the starting base.
Yes, yeah. A common thing I see, because a lot of code bases are quite old, and maybe like mature is probably the wrong word, but a lot of code bases have had lots of different developers that maybe contractors and stuff over time, where it's become, there's lots of different design patterns being thrown in and not consistency. But that's very common, very, very common.
Yes, exactly. As you've observed, a lot of the teams I do have turnover in developers and different practices, so sometimes exceptions and logging, and even those things could have been done in multiple different ways, or the team could also have been working in silos, and it's you look at one part of the code and another one and you could tell it was done by different people. So that's a very common challenge I've observed. And another common challenge that I've also observed is having large classes with business logic and infrastructure all bundled up together to the extent that it becomes really hard to read, hard to understand, untestable, and whenever a new user story or bug fix comes in, it is really, really messy to know how to implement it correctly.
Yeah, definitely. Those large classes with 50 different if statements and they're all nested and then for each is inside, and then
Exactly.
you've got to do a new feature, so you add another if statement and it gets worse and worse. It's like, oh, horrible, horrible, horrible. Anyway, before we dig into hexagonal architecture, just a quick reminder for the listeners that this podcast has its own Discord community. If you head over to the website unhandledexceptionpodcast.com, you'll see a big Discord link there. And I also have a monthly newsletter where I cover stuff about the podcast episode releases, upcoming episodes, and I talk about other stuff that I do too, like the YouTube channel, .NET Oxford user group. And also I put a bunch of news item picks from the last month and a dev comic pick too. So there's a link to that on the website too. And lastly, a quick reminder that this podcast is sponsored by Everstack, which is my own company providing software development and consultation services. For more information, visit everstack.com. Okay, hexagonal architecture. So normally when I look into this, or onion architecture or clean architecture, I see big circle diagrams trying to explain it. So obviously this is an audio only podcast, so we don't have that advantage. So we can do our best though. Now, I guess we can either start with explaining hexagonal architecture, or we can start by explaining what problems this is trying to solve. So I guess you're like the expert at explaining this stuff. Where is the best place to start?
I would say starting at the current reality of most projects, how are they structured, identifying the problem, and then introducing hexagonal architecture simply because it may be a new term for our listeners.
That sounds good to me. So what are the current, well, I would say what's the most common architecture people try to use before they've heard of hexagonal architecture?
Yes, I would say the most common architecture is the free layer architecture, or someone calls it just layered architecture or free layered architecture or CRUD application, whereby someone implements controllers, let's say REST API controllers or MVC controllers. So I'm going to go ahead with the REST API controllers, and then having service classes, and that's where they implement business logic, and finally having some kind of entities which are related to the database. So just to give one example, with .NET, someone may be using ASP.NET to make some REST API controllers. For example, having an order controller, which has HTTP methods for submitting, for creating a new order. So post order, put order, delete order, maybe for cancellation, etc. And then the REST API controller calls a service class. So we could have an order service class and its corresponding interface, which has the methods, for example, create order, approve order, cancel order. And within that service class is where we would have business logic. So, for example, there could be business logic when doing approving order to check, well, firstly checking does the order exist, checking that its current status is in draft, then changing its status to approved, then saving it in the database, etc. So that kind of, any kind of business logic would be inside the service class, and the service class is calling, certain entities like order, and it is also calling, let's say, the DB context, and we have DB context, we have DB set with the orders in order to, let's say, communicate with the database using entity framework. So I see that as, let's say, a common starting point for project. Now, to get to the next part of the question that you raised, which was what are the problems with this? Initially, when we start such a project, which is the most common structure, no one sees any problems with it. In fact, it's the fastest way to start a project. But as time goes on and on, problems start emerging most visibly in this service class. So the order service class, which was initially maybe 10 or 20 lines, later grows to 100 lines, thousands of lines, and we end up with possibly 50 if-else statements, as you've mentioned. So it becomes very hard to read, is one problem. But the other also problem is that we are mixing business logic with all of these entity framework queries, and it can just get really messy having to deal with all of those within one place. And the last problem that also comes in there, not just the coupling with entity framework, but also imagine we need to call other microservices or third-party systems, like maybe calling some ERP or CRM, and then someone might be opening up, HTTP client connection in the middle of that service class. Not only is it additional code, but now we're mixing multiple concerns. We're mixing business logic, is being mixed with database, is being mixed with calls to other web services. So all of this is in one file. The problem is a mixing of concerns and testability. How can we unit test business logic if it's mixed together with database code, if it's mixed together with HTTP client? We can't unit test the business logic. So it's these two problems that hexagonal architecture tries to solve: separation of concerns issue of business logic and infrastructure, and the testability issue associated with it.
Yeah, and I guess does that also solves the incoming, because we've spoken about the outgoing for the database and that being very tightly coupled. But I guess if you put business logic in a controller, then you're tightly coupling it to ASP.NET. So I guess that's the other side of the coupling as well.
Exactly, that's right. So the coupling that I guess I described up to now was just in the service class, which was the outgoing coupling, but there is also incoming coupling, which is the case that some teams don't have service classes, that they put that code into REST API controllers directly. That is one variant that I've seen, whereby the REST API controllers, which is essentially a presentation layer, is then coupled to business logic and everything else. And the other variant that I've seen is teams having both REST API controllers and service classes, but the REST API controllers are also doing some business logic. So that business logic is split both in service and REST API controllers. And then again, that is also another variant of presentation side, like incoming, essentially coupling.
I guess also I could often see that even if you've got a service class, so you've got that separation, that maybe people would pass the same DTOs. So the web API DTO that the browser or some other service is calling, and pass that through to the service. So you've got like the coupling there. And I guess it's like a balance, isn't it? Do you have like lots of DTOs and lots of mapping functionality? Or do you pass the same DTO through and have that coupling? So I can see pros and cons to both really, but yeah, coupling is interesting.
Yes, and on the topic of DTOs, that is a whole conversation in itself. For example, what most teams typically may even do is initially not having any DTOs, but actually having entity framework entities being passed in REST API controllers. So I've seen that as a typical initial starting point. Then later teams switch to DTOs, but using the same DTO across multiple REST API methods instead of having, let's say, separate. Now, the last question, should REST API controllers have same or different DTOs compared to service classes, is one where I see two possible answers. We may get to it, I think, later, since it is a certain detail of, let's say, implementation options.
Yes, that makes sense. So all the different architectures I mentioned earlier, so one of the other ones was ports and adapters. Is it correct to say that they are the same thing, ports and adapters and hexagonal architecture? It just means the same thing?
Yes. So on Alistair Cockburn's article, from what I remember historically, that the first name was ports and adapters. Later, the same thing was called hexagonal architecture, and simply hexagonal architecture as a term became much more popular. But still, both terms do continue to be used interchangeably. There has been confusion regarding the word hexagonal architecture, as in the hexagon. Is there any specific significance of picking a hexagon? And the point is no, it could have been any other polygon. It could have even been a circle or anything. It is irrelevant. The only part that is relevant is that we have something to symbolize our application, which is drawn as a hexagon in hexagonal architecture, and that we have the outside world.
Yeah, that was actually going to be one of my upcoming questions. Why is it called hexagonal architecture? I guess also I wonder if it plays in the fact that hexagons slot together. So if you've got like a whole bunch of hexagons together, then they can talk to each other, but in this decoupled manner, I guess.
Yes, I like that you raised that because, for example, in the case of modular monolith, someone may have the possibility to use hexagonal architecture for the whole application. For example, for this whole REST API, to have one hexagon, but then someone could extend this idea in a more nested version to have, let's say, multiple hexagons and they are talking to each other.
Yeah, that makes sense. So just think about this ports and adapters thing. Can we actually define what a port and adapter is? What those terms mean?
Yes. So let's firstly imagine in our head that we have our application, which is, so we're imagining a hexagon in our mind, and we have this separation. The hexagon itself, it has a clear boundary, and if it has an inside, so it has internals, and then there's the outside world. The hexagon boundary has ports on it. So we have incoming ports, and we have essentially outgoing ports. The incoming ports, they are called driver ports, and the outgoing ports are called the driven ports. So that's where there's, the left side incoming and the right side outgoing ports. So these, I'm just now thinking, should I continue using, the official words are driver ports and driven ports, but actually the more intuitive words are incoming ports and outgoing ports, even though those are not official ones. So I would say for greater understandability, that maybe we could continue with the informal way of speech for the rest of the podcast.
Yes, yeah, I agree with that. That makes sense. Incoming and outgoing is very intuitive, so that makes sense.
Yes. And for the audience, simply to know that I will repeat once more. So incoming is the driver ports and outgoing is the driven ports in the official diagrams.
So just to check, when we're talking before about services and outgoing like databases and things and incoming being that web API, is that what we're talking about with these ports?
Yes. And now we'll get to, I guess, the more precise way. Now, when we think of incoming ports, it simply means that someone wants to send certain commands to our application. I would say that's the simplest way of thinking about it. So someone wants to tell our application, can you please create an order? Can you please approve an order? Can you please cancel an order? So someone is telling us, so we're receiving like an incoming signal. At this point, we have no idea who is sending us these like essentially commands. Is it being sent to us by the REST API, by web MVC, by a console application? We actually don't care. We'll get to what those are later, but all that we care is that we are exposing some doors or windows into our house, so we can think of our application as the house, and we can think of these, I guess, incoming ports as we are opening a door so that someone can tell us, hey, can you please execute this? Then so all of those incoming ports are on the left side of the hexagon. Then on the right-hand side, we are also exposing port, but for a different purpose. For the purpose that we need to communicate with something external, so we need to call something. So our order application needs to call database, needs to call something from the file system, needs to call some ERP, like maybe SAP ERP, needs to call some CRM, maybe from Salesforce. And at that point, we don't want to care about what are the protocols and the technologies behind that thing. So for example, for databases, we are ordering our application, we don't care is it a SQL database or no SQL database. We don't care about is the ERP that we communicate with, do they have a REST API or is it a SOAP service or is it some FTP mechanism? So we don't want to care about those infrastructural concerns. And then this means when we model our outgoing ports, that we model it in terms of what we want to send out in an abstract way. So for example, imagine I need to communicate with an ERP. Maybe I need to send them my order ID and let's say the total order price. And then I have an interface to represent that port saying, here's the data I'm sending you and also what I'm expecting back. And in that interface, I have no idea what will be the implementation behind it. Will it be REST API or SOAP when communicating with that ERP?
And by interface, are we talking about a C# interface?
That's a really good question. Interfaces. So within hexagonal architecture as a concept, they refer to interfaces in the most conceptual way, irrespective of the language. Some languages also happen to have interfaces, like C#. There are also some languages don't have interfaces, but have something similar. Like, for example, Python doesn't have interfaces, but it has abstract classes. And maybe there could also be some other types of languages which don't even have interface at all. So just coming back to C# specifically, yes, in C#, when implementing it, we would be using interfaces. The one way it's easy to say yes to using interfaces is on the outgoing port side. Whoever implements would be using interfaces. On the incoming side, you may have interfaces. For example, you have an interface if you're using application services, where you have an interface for the service and an interface for the service class. But if you are, let's say, using mediator, some, let's say, command handler type of library. In that one, you're not writing your own interfaces, but let's say you're using the mediator interfaces. So in that one, it gets a bit fuzzy in terms of the options available.
Yeah, I guess in that case, is the mediator request, is that the interface effectively, and the response?
Yes. In that case, we would be passing out the iMediator interface in our that would be the interface boundary. So it's either using mediator interface or using our own service interfaces.
So for the outbound ports, would it be correct to say that, like in the context of .NET and C#, that a port is an interface and an adapter is an implementation of that interface?
Yes. So this would mean, let's say we are communicating with an ERP. And we think about, okay, the reason why we need that ERP is because we have to, let's say, forward to them our order. And the other reason why we need the ERP is later to get the order status, because the ERP behind it, there's some manufacturing place or like some production, and they have employees, and the order is, let's say, I don't know, packaged and later shipped. So the ERP knows the actual status. So we define an interface, and it has, let's say, two methods. For example, send order info, where we send the order ID and the order price, because that's what the ERP wants us to send to them. And we have another method called get order status, and we pass it order ID. So that's the interface. And then we have an implementation. And let's say that interface, we call it warehouse gateway or something. And then we have an implementation. Let's say we're using SAP. So maybe we call it SAP warehouse gateway. And that's a concrete class, and it implements this interface. And within that implementation is where maybe you have a HTTP client, which is calling the SAP REST API or the SAP SOAP service.
That makes sense. And it's that implementation that's the adapter side of things.
Yes, exactly. So that SAP warehouse gateway class is an adapter.
That makes sense. So, and then I guess the name you gave the interface gave nothing away to what it was calling, that it was calling SAP. It was just almost like the business requirement rather than the implementation detail.
Exactly. So the choice of SAP is seen as a technological, infrastructural, external world concern. And that's why the name of the interface is not giving away the name of the vendor that we're using. So we're not going to give away, are we using SAP or Salesforce or something else? We're not giving away that. We're also not giving away the protocol. So when naming the outgoing port, we don't have the word HTTP, SOAP, REST. So we're not giving away anything about protocol or communication mechanism either.
That makes total sense. So effectively, using this, like the ports and adapters term, we could conceptually say that we're going to get another adapter that does something else, does the same thing in a different way, and you can plug that different adapter into the same port. So it's like very plug and play, I guess.
Exactly. That's exactly right. So when we had the port warehouse gateway, it may have implementation like SAP warehouse gateway, which is one possible adapter. Maybe there's some Microsoft Dynamics warehouse gateway implementation. So if we have multiple vendors, we can have, multiple adapters for it. Or let's say, imagine SAP is firstly using a REST API, but then later they are switching to SOAP service. So we maybe firstly had a SAP REST warehouse gateway, and later we had a SAP SOAP service warehouse gateway.
Yeah, that makes total sense. Although why someone would move from REST to SOAP, I don't know. I've not done SOAP in a long time. But so think about the incoming adapters then, or ports or adapters. If, for example, you had like a service that was a worker service and it was listening to messages coming off an event bus, like Azure Service Bus or RabbitMQ or something. So your application, that there's nothing inbound to your application. It's listening outbound, but conceptually the message is coming in. That's still an incoming adapter, I guess.
Yes, so it's on the incoming side, and we can discuss how, RabbitMQ, so where your RabbitMQ consumer is on the incoming side, whereas the RabbitMQ publisher is on the outgoing side. So that's an example where one word RabbitMQ, or one technology is on two places. So coming back to the incoming side. So the typical examples of incoming side implementations, i.e. in hexagonal architecture called driver adapters, is, for example, REST API controllers, SOAP controllers, RabbitMQ consumers, Kafka consumers, console applications, MVC applications. All of those are driver adapters. And the whole point is that they end up calling your service interfaces. So if we recall, we had a interface order service, which has that order service interface is the incoming port, which had the methods create order, approve order, and cancel order. We could have had a REST API controller, which has like post or get whatever methods, and it simply calls those service methods. We could have had a RabbitMQ consumer, which is from somewhere receiving a request to create an order or to approve an order, to cancel an order, and it also calls that service interface.
So your application logic, this service, doesn't know and doesn't care what called it. It's got a single responsibility, one job to do. It does it with this input data that doesn't give away the technology that sent that input data. Is that right?
Yes, exactly. So the service interface has no knowledge of who is calling it. So it has no knowledge of is it being called by a REST controller or RabbitMQ consumer. It doesn't care. And the other also aspect to add there is that then it also becomes easy to interchange these adapters. So maybe a team initially started with REST API controllers, and because all of their microservices were directly calling each other, and later they decide to migrate to event-driven architecture, and they decide to replace a whole bunch of REST API controllers by RabbitMQ consumers. It becomes very easy to do because all of this is one-liners, essentially.
Yeah, because it's just changing the adapter and then updating your IOC registration.
So regarding IOC registration, I want to explain the difference between the impact on the incoming side versus the outgoing side. So on the outgoing side, that's exactly correct. Initially, we were registering that, let's say, the warehouse gateway interface is being implemented with SAP warehouse gateway implementation. And when we're no longer using SAP or using something else, we replace it. So in that case, yes, it is a one-liner update within the IOC container registration. But for the incoming side, the part that we have registered in the IOC container is that order service interface is being registered. Its implementation registered is the order service implementation class. That part continues to stay irrespective of anything. Now, as you are switching from, let's say, REST API or to, let's say, RabbitMQ consumers, you may have a one-liner above all this or somewhere which is not related to any specific service class, which is simply switching the overall mechanism. So yes, it's a small impact.
Yeah, that makes sense. I think what you mentioned RabbitMQ, so one technology I use quite a lot is mass transit, which is an abstraction over message brokers. And you actually end up with a consumer class, which is kind of, I quite often put application logic in there, but I guess if we're looking at what we're talking about here, that would be the wrong place to put it. It's almost like a controller, I guess. But then could I almost say that that's my hexagon and mass transit is the adapter, and I can just, because it's, I guess, one thing I like about the consumer in mass transit or whatever, or even mediator or mass transit, whatever, that it is still with single responsibility. Like with a controller, you can have put post, as you mentioned before, put post, get delete, and it becomes lots of responsibilities. So I definitely like moving business logic out of that. But with mediator handler or a mass transit consumer, it's one execute method or handle method per your class. So it feels like that redirecting to a service is kind of like an unnecessary redirection, I guess.
Exactly. And since you brought this topic into discussion, I now want to say the alternatives in implementation of these incoming ports. Hexagonal architecture provides us a choice whereby both of these decisions are fine. So what some developers may choose to do is choosing to continue using application services. One example of it was the order service, whereby developer writes the interface, writes the implementation, and typically that interface has multiple methods. So like order service has, let's say, 3 or 5 methods. That is one approach. We can say that those are coarse-grained incoming ports, because one incoming port, like, it has lots of different methods that it provides. The other alternative is fine-grained ports. One common example that may be familiar is the usage of mediator. So this means instead of having an order service with those 3 methods, create order, approve order, we would instead have create order handler, approve order handler, cancel order handler, and each of those would have a single execute method. So we would just cut and paste from the service class. In that case, the service class interface, they no longer exist. They are deleted. And then your driver adapter, like the REST API controller or RabbitMQ consumer, would be doing mediator.send and passing in a create order request or a approve order request or something like that, and it gets executed by the corresponding handler.
Yeah, that makes sense. I must admit, I'm a big fan of the handler pattern. Whether it's using mediator or not, just the fact that you've got a class that supports dependency injection and it does one thing, execute. It's not got lots and lots of stuff, so very single responsibility principle. And also the class name does what it says on the tin, so you can look at the class name or the file name and you know exactly what it's doing. It's like get order or create order. It's very clear from that. I do like that pattern. So it's good that that fits into this architecture.
Yes, I'm a big fan of that too, and indeed, that's the approach which I tend to prefer and promote. Typically, with teams, I start with application services because that's what they're familiar with, and that's what they sort of already have. But then switching over to this more fine-grained approach. And the other aspect that I also like within that more fine-grained approach is that it is exposing essentially the use cases immediately through the file names. And that also happens to be a key contribution that Clean Architecture brought, because within Clean Architecture, Uncle Bob essentially took hexagonal architecture. But one important decision that he made on top is specifically he will not have application services, but instead these use case handlers.
Just looking at the diagrams, comparing like you said, clean architecture and then hexagonal architecture and onion architecture and stuff. They're all like they're using different terms, like you say. So you've got like use cases and things. I guess I can picture this being one thing that confuses developers, because if we look at these diagrams, how the circles like with different layers on the outside. On the outside, it tends to be the UI database, even tests and things. And we've spoken about incoming and outgoing. And I suppose developers are used to from a data flow where you've got a UI or something calling some application logic, which then calls up to the database, so maybe left to right, where if you look at the diagram, the left and the right, so the UI and the database, are on the same outside layer, so the outside. So I guess like from my understanding, this is more about dependency direction rather than direction of flow. But is there a good way that we can explain how that, I guess it's dependency inversion, I guess, how that becomes a circle?
Yes, it is a good topic. What's the relationship of these architectures? I would say the most fundamental architecture here and the crucial contribution was actually hexagonal architecture. I see all of these as derivatives. So the way I see it is hexagonal architecture is the one that brought in essentially the whole concept that we have the application, that we have the outside world, and that the application does not depend on the outside world, but instead the dependency is like inwards. So stuff that is on the outside, the adapters, which communicates with the external world, that adapters depend on the ports, and that the ports don't depend like on the adapters. So the dependency is going inwards towards the hexagon. Now, as I said, the actual shape hexagon is not relevant at all. So what happened was with onion architecture, instead of that hexagon, it got replaced by a circle. And they also added another circle over the adapters and removed the concept of left and right.
To make it even more confusing.
Yes, and this is why I personally prefer always showing to teams the hexagonal architecture diagram. I find that clearest, the ones of onion architecture and clean architecture. It is very confusing to see presentation and the database on the same circle. And I guess what I would like to say is what I see maybe as the essence of the difference between them. So hexagonal architecture defines that essential boundary of separation of our application is separated from the external world by the ports, and adapters implement the mechanism of communicating with the external world. That is the essence. Hexagonal architecture does not prescribe what are the layers within the hexagon. So how do we structure our application? It does not prescribe. So are we going to have order service, or are we going to have those command handlers? It is not prescribed. Are we going to be having inside plain data structures for our order and having all the logic in services? Or are we going to use, object-oriented programming and have a rich order class with methods and encapsulation? It is not prescribed. But in architectures like clean architecture, it is prescribed. So clean architecture takes hexagonal architecture as the base, but adds additional restrictions on top. So as I said, hexagonal architecture does not care about are we using application services or those like request handlers. It does not care about granularity of the port. Both are fine in hexagonal architecture. Clean architecture, Uncle Bob specifically chose the fine-grained, those request or command handlers. The other part where there was a specific design choice made in clean architecture is the layering within the hexagon. So as I said, in hexagonal architecture, it does not say what are your layers, how will you structure your hexagon. Clean architecture does say what the layers are. The layers will be use cases. For example, create order handler, approve order handler or use case, whatever you call it. And another layer, entities. So there's going to be a layer with entities. Maybe it's going to be like order entity, product entity. And furthermore, those entities will be rich entities. So the order will have a constructor. It's going to have methods which encapsulate its, access. The order may have methods on itself to approve the order. Order itself knows how to calculate its price. So the calculation will not be in the service, order service, it will be in the entity. So notice how all of these are additional design decisions that are made within, let's say, clean architecture. The other aspect is, in terms of unit testability, only hexagonal architecture is the minimal requirement. So just to summarize, if we want to get separation of concerns and testability, hexagonal architecture is the foundation. We may go further into its essentially derivatives, onion architecture, clean architecture.
It does sound like hexagonal architecture gives you a lot more flexibility and is a lot less restrictive, especially if we're using these technologies like we've spoken about, like mediator and mass transit and all that kind of stuff. It's kind of good that you touched on testability as well, because I guess that really helps, because if all your application logic only knows about interfaces, so could we almost describe, if you're mocking an interface for your tests, that mock is just another adapter?
Yes. So that mock, or the more general word, test double, because we may be using mocks, we may be using fakes or stubs or whatever, it indeed is an adapter. So this means we can have real adapters, like, you know, with the SAP implementation or Microsoft Dynamics implementation, Salesforce implementation, all of those we can say, or database implementation with entity framework, real implementations. And then we have also for each port, we have a test double implementation, which might be a mock or a fake or any other test double.
Do you find that like more recently I'm seeing doing any kind of mocking as being frowned upon, and like I personally use like Docker and real databases and test containers and all this kind of thing. Do you think things like that are making hexagonal architecture less needed? I guess I'm trying to find the best way of saying it, but you know what I mean.
Yes, I like that question because I spent several months also thinking about it, and I did get asked that question a lot. So first of all, let's start historically, and then we'll get to the present. At the time when hexagonal architecture was essentially conceived, the only thing that existed was, okay, there existed real databases. There was no concept of Docker at that point. And at the time that it was made, there were cases. I remember Alistair in one YouTube recording describing the case of working with a team whereby the team people who owned the database needed to make certain changes. And the application team, since they were directly calling the database, they were blocked in development due to that dependency. So then that was part of the reason of introducing the interface. So that's just a short story of why any concept of test doubles were introduced at all. But then we come to the next point about, okay, mocking in general. So the only part in hexagonal architecture where any form of test doubles is essentially is being used is only on the outgoing port side. So this means not within the hexagon. So there is no over mocking. We are not mocking every single class that exists. We are only mocking the outgoing ports. That's one important thing to note. Then we come to the next question, which is currently, if we have Docker and it enables us to spin up databases, you know, fast, that was also not possible in the past. There also now exist test containers so that we can even run isolated tests without a shared database. That was also not possible in the past. So what happens now is when someone is using test containers, that they can get fast running tests using the real database, and the tests also happen to be isolated. In other words, achieving the same characteristics that we would achieve if we had used a test double. The only difference I still see is the test double would be an order of magnitude faster due to it being purely in memory. That's the only difference I see. So I think that now it's become a bit of a blurred line. I still personally am currently using, and when I work with most teams, recommending usage of test doubles. However, looking at test containers, it is still of a gray area, which I would like to explore further. Currently, I do not have to say any particular stance towards that. For me, I do not find that against the idea of hexagonal architecture.
Yeah, I guess from the test point of view, you could argue that if you're not mocking and using like Docker and test containers and stuff, like you don't need to use interfaces at all. But all the other benefits, like ignoring the tests, all the other benefits we described before, like plug and play and being able to swap out implementation details, that still applies. Like, and it's so quick to, especially if you're using like ReSharper or Rider or anything, you can interact and move around between interfaces and the implementation so easily. Then it's not like it's costing, and you can create them very quickly. It's not like it's costing a lot of work. So so the benefits we described before, it makes it worth it, even if you don't need it for the tests.
Yes, and that's where I actually find the stronger argument in terms of why I still prefer, usage of interfaces. First of all, the impact on the developer's mind, that they can think about domain terms and like that without thinking about, is it going to be SQL, is it going to be stored procedures, is it going to be entity framework, is one benefit that I see, that conceptual benefit. The other benefit that I see is in terms of later, let's say, optimizing database performance. So even if we're not going to swap out, databases, we're still sticking with, let's say, entity framework or whatever we have, I would find that, and we have problems that we discovered on the database, maybe some queries are slow or something like that, it is easier if you open up one file, which is the adapter, and it has all the entity framework code. It's a lot easier to read and think about database performance versus having to look at hundreds of lines of entity framework spread out all over business logic is an argument. Now, the one about database swappability, which was seen as a whole pro when hexagonal architecture was conceived. However, in practice, that's the one that I found happens relatively rarely. Although it may happen, but it's rare. So that's why I use it as a small argument. But the one of separation of concerns is a big argument. The other also big argument that I personally see is when when you have upgrades in ORM. I remember a case with Entity Framework. It happened several years ago where Entity Framework changed the way it does the inheritance mechanisms. I can't remember, was it with discriminants or I can't remember the word. What happened, but essentially where a whole team was blocked in upgrading their project because it all had Entity Framework dependencies everywhere, all due to that reason. Whereas here, when we model our application separate from Entity Framework, we are not worried about restrictions of Entity Framework nor about its changes in the upgrades. So if Entity Framework does upgrade, only a small portion, only the adapter is affected.
Yeah, and I guess even when we talk about Docker and stuff and Entity Framework and databases, we're talking about stuff that can be spun up locally in Docker, but you've also got outgoing dependencies, which in your test you can't do, as in it could be a third-party service that you have no control over. It could be, even if you've got a microservice architecture and locally when you're running your test, you don't want to spin up every single one of your services, all your services. In that case, just being able to mock that out actually is quite useful.
Exactly, and that's the one where we don't have a choice in terms of we don't have a choice to debate, can we use the real thing, can we not, because that one has a very clear impact on testability. Now, Alistair Cockburn, again, in hexagonal architecture, it was simply outgoing driven ports. There was no sub-classification of them. Later, as I worked in practice, I see it that certain things are more internal to the application, like database, it is owned by, let's say, the monolith or the microservice. And that's the one where I said someone could make the argument of possibly using test containers because there's a very clear ownership. But there are certain other things which are very distant to us, which are not owned by us, which are third-party systems and other microservices where there is no choice but to abstract it away, simply because if we call the real instances, then that would be essentially going in the realm of end-to-end slow tests, which is what unfortunately teams are doing who are not using hexagonal architecture.
Yeah, definitely. I'm aware that we're quickly running out of time, but there is one extra question I wanted to ask. So using hexagonal architecture, are there any common mistakes that you see people make?
Yes, so I would say that the first problem, the biggest mistakes is that teams are not even aware of the existence of hexagonal architecture at all, and they continue, let's say, working with the traditional layered architecture and missing out on all that separation of concerns and testability. Now, when teams do start using hexagonal architecture, I would say some challenges that I've observed is in, let's say, knowing, what are the ports. So I've had cases where teams, especially for the outgoing ports side, is where I've seen issues that, let's say, teams might be naming their interface, like their outgoing port, as like ERP or SAP. Or even within that port, having, how should I say, JSON or HTTP statuses, whereby that outgoing port is actually not abstracting away the infrastructure at all. That is one example of a mistake. The other aspect, let's see, on the incoming port, again, if someone within their service classes is passing around HTTP raw requests or headers or returning HTTP status codes, having some presentation concerns in the service is another problem. Or even having, again, logic accidentally being split, instead of centralizing the logic within service classes, that again, some of the logic starts leaking out in the presentation, or essentially leaking out business logic into adapters is another mistake that I've seen. I would say those are some core challenges that I've seen.
Yeah, I can picture like if someone has an outbound interface and they write methods like, I don't know, get a document from Azure Storage or something like that. Then don't put the Azure, just say get a document. Then the incoming side, like we've spoken about Mediator before. So one thing I see quite often when people use Mediator is maybe the Mediator handler is returning a HTTP status code, which then gets returned by the controller, when actually it should be returning an enum with a name that is relevant to what that handle is doing. So I think it's just like avoiding that coupling, I guess.
Exactly. So understanding that anything that's done within the hexagon and its ports, that it should all be in terms of domain terminology and not technology implementation, whereas the adapters are supposed to do translations. So let's say the order controller should be responsible for understanding the response from a service method or from mediator handler, and then converting that into the appropriate HTTP status.
Yeah, that makes sense. Makes sense. So as I say, we are running out of time, but shall we do dev tips before we wrap up?
Yes.
I will let you go first.
Okay, great. So I do recommend for our listeners to take a look at Alistair Cockburn's Hexagonal Architecture article. So it's alistair.cockburn.us/hexagonal-architecture, or you can just Google search Alistair Cockburn Hexagonal Architecture. This will provide you useful information about foundational aspects of hexagonal architecture. And you can also look at some of my meetups as well on YouTube for learning more about hexagonal architecture. And I do recommend that maybe you make a small GitHub project where you make your typical CRUD application and then you try out hexagonal architecture and see how it works out for you.
That sounds good. And I can include a link to all of those in the show notes. So listeners, if you just jump over to the show notes, you can see those. So my dev tip is, it's not really related, but one thing for a current client we're really trying to focus on is adding more and more observability. And I find that's one of these things, just like, I don't know, like tests and security, a lot of people just like delay and put off and everything. And observability, it's making such a difference. We happen to be using Grafana for the dashboards and stuff, but it's kind of whatever you're using, whatever tool you're using, just take a moment and as you're writing code, thinking about how the observability of that code, of that feature, whether if you're using OpenTelemetry, just making sure you're using like proper traces and like adding proper metrics as things happen, and thinking about if an issue happens with this code in production, what would I, if I'm a support person, if I'm looking into it, what would I want to see in Grafana or whatever the tool is that would help me diagnose this issue? Because I think that's just one of these things that gets left. And it's an important thing to be as well as thinking about security whilst you're developing code, also think about the observability of it. Cool. So before we wrap up, where is the best place for listeners to reach out to you if they have any questions or want to chat about hexagonal architecture?
So I would say I would recommend listeners to follow me on LinkedIn and Twitter. There will also be some links regarding Discord, since I have also the Optivem Discord community, which is where there's a channel about books and courses that I plan to release, including about hexagonal architecture. So that's also a place where listeners can ask any questions and ideas, which I may take into account as I'm writing a book about hexagonal architecture. And lastly, I also recommend joining the Tech Excellence community, which is where we have various meetups that do cover topics like hexagonal architecture, clean architecture, domain-driven design, test-driven development, etc. So I recommend that as well.
Sounds good. And as I say, I'll include links to all your socials and things in the show notes. And also, you're now on the podcast Discord as well. So I'll add you the guest role so that you'll appear at the top with the other guests. So it'll be easy to find there as well. So cool. With that, just a big, massive thank you for joining me on the show. It's been really fun geeking out. And I'm hoping that without diagrams, with an audio-only podcast, we've actually managed to help listeners understand all this stuff.
Yes, definitely. I found this to be a really enjoyable, a really insightful experience. And I hope that it is useful for the listeners just to get a rough idea of what hexagonal architecture is about, and hopefully as a motivation to research more about it and read more about hexagonal architecture and to try it out further.
Yeah, definitely. And just a reminder to the listeners that on the podcast website, each of the episodes has a comment section at the bottom if you do want to comment on episodes. So with that, yeah, it's a massive thank you for everyone for listening. And a quick reminder that this podcast is sponsored by Everstack, which is my own company providing software development and consultation services. For more information, visit everstack.com. And if you're enjoying the podcast, please do help me spread the word on social media. I normally use the hashtag unhandledexception. And I can be found on Twitter at Dracan, which is DRACAN, and my DMs are open. And my blog, danclark.com, has links to all my socials too. And then, as I mentioned before, all the stuff we've spoken about today will be linked in the show notes, which can be found on unhandledexceptionpodcast.com.